Hello there. My name is Vincent Odanga. This is my name. I know right now you are scrolling down looking for entertainment content. But please just hold on for a minute because what I want to talk about is very important, especially for uh, civil engineers, technicians, and students pursuing a course leading to a civil engineering. Guys, today I want to talk about what we call reinforcement. Reinforcement. So in today's lesson, I will discuss various items about reinforcement. Number one is the definition of reinforcement. Number two, I will talk about why reinforcement is needed in concrete. And under this, why reinforcement is needed in concrete, I will be able or I will explain various concepts regarding to compression zone, tension zone, and under compression zone and tension zone, I will explain various types of beams. For example, a loaded, simply supported beam, and under this, I will draw a loaded, simply supported beam and show you how a compression zone and tension zone is represented in this beam and where the reinforcement is needed in this beam. Number B, I will talk about the cantilever beam, the cantilever type of beam, and I will also draw a compression zone and tension zone for this cantilever beam, and I will show you where the reinforcement is needed in this beam, whether in the top of that beam or in the bottom. And then the last one will be a continuous beam. I will also draw a compression zone and tension zone for a continuous beam so that you may know where the reinforcement is needed and where the tension reinforcement is needed and not. And then the last item, I will talk about common types of reinforcement materials. So under common types of reinforcement material, I will talk about steel reinforcement. This is the most commonly worldwide used material. And then fiber reinforcement, fiber reinforced polymer, and the last one will be bamboo reinforcement. So stay tuned as I start from the definition up to the last item. So reinforcement, I'm sure you have heard this word and you have used it several times, but maybe some of you know the definition of the reinforcement and some of you don't know the definition of reinforcement. So what is reinforcement? Reinforcement is the practice of adding material. Example include steel bars or rebar or mesh to concrete to enhance their tensile strength and overall durability. So why do you think reinforcement is needed in concrete? Why do you think reinforcement is needed in concrete? So number one, we have concrete is strong in compression but weak in tension. So concrete is strong in compression but weak in tension. So I'm going to explain the compression zone and tension zone using various types of beams. So the first one, I will begin by a simply loaded, simply supported beam. Loaded, simply supported So under this, I will draw a loaded, simply supported beam, and then I will show you how this beam will bend and where the compression zone will occur and the tension zone, and where the reinforcement is needed, either in tension zone or in compression zone. So you will be able to know between the two. So as you can see, this one is a beam. In blue is a loaded beam at the center with a point load W. So if this beam will bend in a circular form. So this is how it will bend. This is how it will bend. As the beam bends, the top of this beam will reduce. It will compress. As you can see, it is compressing. It is reducing. As the bottom part is increasing. So the bottom part is what we call the tension zone. So the bottom part, it increases, and the upper part, it will reduce. So as this bottom part it increases, it develops cracks. So these are cracks, these are cracks. So as it develops cracks, if you don't reinforce at this bottom part, then the beam will fail. It will fail due to excessive bending and due to cracks development. So we provide reinforcement in this tension zone, in this tension zone, because we have said that concrete is strong in compression but weak in tension. So the upper part is in compression zone and the bottom part is in tension zone. So for a simply supported beam, the reinforcement will always be at the bottom part of that beam because of the tension zone. And to be more precise, a simply supported beam is a beam resting on two supports only. As you can see, this is support, this is another support. So support A, support B. So support A will produce a reaction, which is RA, and support B will produce a reaction, which is RB. And this is a neutral axis. So that is how a tension zone and compression zone is represented on a loaded, simply supported beam. So we move to a cantilever beam. So this is a cantilever beam. A cantilever beam is a beam which is permanently fixed on one side and hanging on the other side. As you can see here, it's permanently fixed, but it is hanging on the other side. So if we introduce a load, which is W, at the hanging side, so this is how the beam will bend. This is how the beam will bend. So the top of this beam will be in tension and the bottom will be in compression zone. So for a cantilever beam, the reinforcement will always be provided at the top of the beam. So when you design such a beam, know that the reinforcement will be provided at the top side of this beam. We now proceed to a continuous beam. So this is a continuous beam. A continuous beam is a beam resting on more than two supports. It can be 3, 4, 5, and so on. So that is a continuous beam. So for such a beam, this is how it will bend. So this is the original beam, the one in blue. But if it bends, this is how it will behave. So at the support, it will experience hogging. Support, it will experience hogging. And in between the supports, it will experience sagging. So here is sagging. Also here is sagging. And here is hogging. So here is hogging, here is hogging, here is hogging. So the negative sign, it means negative moment, negative moment, negative moment. And positive is positive moment, positive moment. So where there is negative moment, this is where it experiences tension zone. And therefore, reinforcement will be provided, the tension reinforcement will be provided at the top of this support, at the top of this support, at the top of this support. And then in between the supports on this span, at this span, the tension reinforcement will be at the bottom of this span, also at this span. So that is all about concrete is strong in compression but weak in tension. So through various explanation using these sketches, the first one, it was a the first one was a simply supported beam, a beam resting on two support, and the second one, it was a cantilever beam permanently fixed on one side but hanging on the other side. And this one is a continuous beam. So beam resting on more than two supports. So that is all about the illustration of how concrete is weak in tension but good in compression. We now proceed to why reinforcement is needed in concrete. Reason number 2. This was reason number 1. We proceed to reason number 2. So reason number 2 is durability and safety. So it ensures structures are ductile. And what is ductile? Ductile is the ability of a material to undergo significant plastic deformation under tensile stress before fracturing. So this one is well explained in stress strain curve. So stress strain curve, where a material is loaded under various loading condition, and then a curve is produced to show the changes of these materials under various loading. So you can check this in strength of material. You can check this in strength of material by Kumi. So this one is well explained in this book, Stress Strain Curve. So they bend or deform before failing. So reinforcement, they bend or deform before failing, giving warning instead of collapsing suddenly. So that is reason number 2. We have so many other reasons, but these two are the most important reason as to why reinforcement is needed in concrete. So I will proceed to common types of reinforcement materials. I want to proceed to common types of reinforcement materials. So these are the common types of reinforcement materials. Number one, we have rebar reinforcement. No, we have steel reinforcement. Sometimes we call it rebar. And then we have the fiber reinforcement, another fiber reinforced polymer. We have bamboo reinforcement. This one is used as an alternative. So I will talk about this steel reinforcement alone, and the other one you can do more research about them. So under steel, I will talk about why steel. I will give reason as to why steel. This is number one. Then number two, I will give you the sizes in diameter for this steel from 6 millimeter all the way to 40 millimeter, and I will show you where a certain size is used, maybe for slab or a column. And then I will also talk about types of steel reinforcement types. Under types, I will talk about milled steel. Number two, high yield steel deformed bars. And then number three, TMT. This is a thermo mechanically treated bars. And then the last item, I will talk about forms of steels. Forms. Under this, I will talk about longitudinal bars, and then stirrups and ties, and then mesh. So it is mesh or welded wire fabric. Example include BRC mesh. So I will only talk about steel reinforcement, and we start right now. So steel reinforcement, why do you think steel is the most commonly material used in concrete? So why steel? Number one is high tensile strength. So complement concrete's weakness in tension. So steel, it complement concrete weakness in tension. Then number two, we have ductility. Bends before breaking, giving warning before failure. Number three, thermocompatibility. So expand or contract almost the same as concrete. We have good bond, ribbed or deformed bars grip concrete tightly. Then economical and readily available. So that one is self-explanatory. And now we move to the sizes of steel reinforcement. So we have 6 millimeter, 8 millimeter, 10 millimeter, 12 millimeter. So this one are commonly used in slab design. And then we have 16, 20, 25, 32 to 40. So this one is for beams, column, and foundation. So these are the diameter of the sizes of the steel reinforcement. So, but the selection of the size of the bar and where to use, it depends on the design and analysis of the structure. So you can't just choose anyhowly the diameter to be used maybe in slab and so on. So it depends on the analysis and the design of that structure you want to build. So how do you calculate the weight of this reinforcement steel bars? So to calculate the weight, we always use this formula, d square over 162. So this one, it will give you the weight in kilogram per meter. For example, 10 millimeter diameter, it will be 10 square over 162. So this one is equal to 10 square over 162. 0.6173. So kilogram per meter. So kilogram for full length is equal to 0.6173 times 11.75 meters. So the length of the bar is always 12 meters, but sometimes it may not come as a 12-meter length because of the construction of the steel. It can be either 11.75, 11.85, and so on. So you will multiply by the approximate value, which is so close to 12 meters. So this one is equal to 11.75 is equal to 7.23 kilogram for one full length of 10 diameter bar. So for the other bar, you can still use the same formula and it will give you the answer. So types of steel reinforcement bars. Number one, we have the milled steel bars, MS. The yield strength is 250 Newton per millimeter square. And this bar is smooth, round. It has smooth and round surface. And due to this smoothness and roundness of this bar, it forms a poor bonding with concrete. You go to number two, high yield strength deformed bars, or HYSD. So this bar, it has ribs on surface, and due to the ribs on surface, it forms a better bonding with concrete. And then the yield strength is between 415 to 500 Newton per millimeter square. And it is widely used in beams, slabs, and columns. Let's go to the last one, which is TMT, thermomechanically treated bars. So we have the third one, we call it TMT, thermomechanically treated bars. So this one are a modern reinforcement bars, and they have high strength plus ductility. So common grades are FE 415, 500, and 550. So, and they are a resistance to corrosion and earthquake forces. And then you have the last one, which is pre-stressing steel. So high strength wires, strands, or tendons used in pre-stressed concrete beams, bridges, and long span structures. So you can learn more about this in concrete technology. Under pre-stressing steel, we have post-tensioning and pre-tensioning. So you can learn more about this in concrete technology. So the last item to talk about is forms of steel reinforcement. So number one, we have longitudinal bars. Then number two, we have stirrups and a tie bars. And then the last one is mesh. So this one is welded wire fabric. I think I talked about this sometimes back, and I'm not going to repeat. So what I'm going to do, I will copy the link in the comment section so that those who are interested to go about or to read or to watch that video, so that you may get more about this. So I end there for today. If you have any question, you can ask through a comment section and I will be able to answer your question. So thank you for your time, and remember to subscribe and hit the notification bell so that you may be the first person to be notified when I upload a video. In my coming session, I will start designing column to BS 8110. That is short column and long column. So thank you for your time.